could really understand what was happening. So let's go to the Q&A. We have something like, for now, 13 questions on list. And I'm really happy to start. I have the first question comes from Lotfi Chelali from Algeria. And I would really like to turn this to Martin, but Phil, if you want then to comment on this also, you're really welcome. So for planning a single frequency network with one main pilot station and several relay transmitters, is it recommended to initially use an omnidirectional radiation pattern and then, after performing some analysis calculations, to adjust the radiation pattern?
No, it's difficult to say from this position. If the pilot station or the focus transmitter is also with a high power, so it maybe works with the omnidirectional. But yes, on the other side, if you start with omnidirectional, you can afterwards check who you have interference and then cut the pattern in this direction to get a nice signal to noise distance. Yeah.
Okay, one more for you, Martin. Do you think at the beginning it's advisable to fix the launch delay of the pilot station's transmitter at 0 microseconds manually from the beginning of the planning process, and then to add the delay to the other transmitters in the SFN?
Yes, I would fix the time for the first station to 0, but not to 0 because you can't go backwards to minus time. So I would start with 1000 microseconds for the whole SFN. So you have a delay for the whole SFN with 1000 microseconds, and then you can test and try to get a better interfering situation with playing with time delays.
Okay, thank you. So Phil, I have a question from Alex Kurz from Gateser for you, and he is curious why you are not using an internal EDI to ETI converter and an internal GNSS receiver on your DAB transmitters, because of course this is now commonly available on transmitters. And I think it's an interesting question.
I think it's a great question. It's a very good observation. So the project that or the design that I was discussing earlier in the slides represents a requirement for Arqiva to enable EDI in our platform without necessarily having to replace all of the transmitters in one go. So the transmitters in our network are of various ages and capabilities. Some of the transmitters do not have native EDI decoders inside the transmitter. Of course, our approach going forward is that any transmitter that we re-engineer will have EDI native inside the actual transmitter, and we would like to think we could take advantage of either using the ETI or the EDI native inside the actual transmitter. I hope that answers the question.
Yes, I guess so. Actually, I must also say we have a similar situation because when we started to roll out the network, actually EDI was not yet standardized. And so for a long time, we had, let's say, legacy transmitters, which only were able to accept ETI, sorry. And therefore we had, let's say, to rely on ETI as a basic transport mechanism, and are now implementing also EDI. Phil, a question from Joan Carre.
But sorry, Hans, but just so I agree with you on that point, and it is really it's not a technical reason, it's a legacy reason, and when you've got over 1,000 transmitters that all need to continue to operate in your DAB network, it's about long term. We will go EDI everywhere, of course, but in the medium term, whilst we still got some of the legacy interfaces, we still need to use ETI. So sorry, Hans. Yeah.
No. That's exactly. Let's say, I think it's a common issue of if you started early. So Phil, another question from you, as I said, from Jean Carré from Digris, Switzerland. He's asking you. You referred to PTP as an alternative time reference. Could you clarify your position regarding MSF at 60 kilohertz? Has this option been evaluated as well from Akiva?
Yes, we have thought about 60 kilohertz MSF, but our initial investigation suggests that it might not be accurate enough for our purposes. I think when you start looking at ELARAN, perhaps if that was a service that was deployed, perhaps around 100 kilohertz, then that might be a different thing than the way in which the time impulses work on ELARAN. But we have had a look at the 60 kilohertz service, and we're not so sure that that's going to be able to provide the resolution that we need.
Okay, yeah, good. Then this is a question from my side to basically all of you. Because this is something we have been discussing also internally. I mean, I can understand a situation where you have multi-band GNSS receivers on all of your network. But what happens if you have multi-band receivers and legacy GPS receivers? Because as far as I understand, the PPS of the different systems is not really coherent, and therefore might this create some issues, or is the PPS signal actually coherent with all the satellite systems? Because in the end, what you really need for your synchronization is the PPS signal.
I don't know. I don't know if it's exactly the answer, but I mean, from what I'm hearing now from some colleagues, it seems that the modern receivers, the chipsets already, are able to more or less correct the different PPSs that you are receiving from the different kind of constellations. So at least that's the idea that I got. I mean, we can really ask further and maybe put a clear response on the chat for whatever is attending the seminar. But I think that in general, the fact of using different constellations or different bands, in the end, the chips are already, let's say, ready at least. But that's from the chips on the newer models. But if you are keeping the older models, I'm having here one colleague that maybe can help on the question. But
well, I know for sure that when dealing with newer chips, they give you the chance to use a certain time base in order to give you the final PPS. And more or less, they always correct the PPS position based on that time base. So it doesn't matter if you switch from GPS to Galileo to GLONASS to Beirut to whatever, that it will remain more or less the same. But if you are mixing the signal with another GPS legacy ones, I don't know what should be expected on those older modules.
It's an interesting question that you raised also internally there. I mean, and probably it's not a situation that has been really tested too much on the field yet. I mean, so that's something that maybe is worth experimenting a little bit and see what is the reaction of the network on that.
Yeah. Phil, do you have any experience on this?
I think it's quite similar, really, to what Lewis has said. Certainly, we have many multi-constellation GNSS receivers, and we're able to use all of those and derive, a 1 pulse per second, which is able to be used across all those different constellations. So I think it's probably aligned to what Lewis has said. We maybe need to do a little bit more thought about that offline.
Yeah, thank you. I think it's an interesting point we have to consider. I have another question for Martin. Martin, are you still there?
Yes.
In your presentation, there was an interesting slide about how you, let's say, adjusted the synchronization issues by changing an antenna pattern in your network.
Yes.
Yes. Do you think that this, and let's say adjusting the tilt and the pattern, are enough to correct the synchronization? So do you think that you can really shield the emissions in the direction of the other transmitter enough just by correcting the pattern?
Yes, it works. It's on us to design the pattern and to prevent for self-interference.
Okay. And one more question. Still, this comes from me. How do you monitor? We heard this from Phil. How do you monitor or SRG, SSR monitor the SFN compliance of the transmitters? So Phil told us about, especially about the TTM they're using, and of course also on the verification of the storage time on the transmitters. Are you using similar strategies, or?
Actually, we only use the monitoring systems integrated in the transmitters to control the synchronization of the network.
Okay, so that's something also we are doing, and unfortunately, what we have seen actually in the past is really sometimes a transmitter slipping outside the synchronization without knowing it, basically, and that's the worst scenario.
That's the worst scenario, and that's still the risk for the SFN. Yes.
Yeah. So you do not use.
Yeah. I was going to say, Hans, that's exactly the reason why a number of years ago now, Arqiva developed the in-house TTM monitor. Is that, as you say, when a transmitter slips outside of its window and everything looks good, then you can end up with timing problems, and they're quite difficult to find sometimes.
Okay, yeah. Do you use external receivers? I mean, there are these DAB receivers which can monitor the reception. They can also receive GPS signal to, let's say, to do a SFN verification. Is this something you have implemented in your monitoring system?
On one point, we have monitoring on our office building, but nothing anymore in the whole Switzerland.
Okay.
Actually.
Phil, well, you have the TTM modules in your sites already.
Yeah, so every transmitter has a TTM, and that's directly connected to our operations center. So if we see one of the transmitters moving in time, then our operations center will then remotely connect to the transmitter to see what's going on.
Okay. Luis, I have a question from you from Eivind Engberg. He asks if traders will participate in the Andoya Gemma test, which seems to be a possibility where you can test transmitters against GPS spoofing. Are you aware of this?
No, I was not. I was not aware of this kind of. I mean, I don't know even what that is, but I mean, I will talk to Avin because we have been participating in a conference that he's mainly organizing in there in Norway. But I don't know if
Okay.
he's referring to the same kind of conference where maybe this year they will do some kind of additional kind of thing, or if it's a different event. But I mean, if that's something that is there, it would be good to really, I mean, not just ourselves, to try to bring more manufacturers there to see if we are more or less all getting together to the same kind of conclusions, because in the end, some of these features are new into the devices, and it's good to see if we are all behaving in the same way, or some of them are detecting jamming circumstances in certain conditions and others don't. I mean, so it would be interesting to play with that. I mean, I will talk to Avin on after the show to after the conference to try to see when is that happening, how that goes. Okay.
Okay. Yeah, thank you. I was just going through the questions, and we are a little bit running out of time. Yeah, so many interesting questions here.
I just saw one.
Yeah,
It's just to go quickly on it because it was asking about synchronization mixed together with the idea of using EDIs or ETIs, and I would say
yeah,
it's a totally separate thing. Okay, so you can use EDIs or ETIs and continue using the GNSS synchronization mechanism in order to synchronize the network in SFN. Even I would say that modern transmitters have the capability to seamlessly switch between the two different inputs. Okay, and I would say that it's. I mean, I saw the question, but I think that the question, I don't know if they were planning to ask other thing, but from my perspective, it's two different things. You can use one input or the other, but that's not really affecting whatever synchronization method you're using when you are using satellite-based one. Okay.
yes, I agree. Probably it's more like I can just relate this to how we do distribution. For example, we have ETI over satellite and EDI on terrestrial networks. And this, of course, creates some issues in the distribution time. But this is something you can calculate and analyze and prevent before
Yeah.
distributing the signal.
Yeah, but it's more related to that than to the proper synchronization in SFN out of the transmitter. That's the idea, I would say.
Yeah. I have a question from Jasmine Bendiaf. Should we limit the power output towards the sea to prevent excessive propagation?
I mean, that's probably more a question of the network planning tools to really see how far you could just reach, and that could be affecting other neighboring countries or things like that. I don't know what the network operators are doing on that side. I mean, probably maybe Phil or Martin can. I mean, Phil mainly as they are surrounded by water everywhere.
Yeah, I mean, I think you're right, Lewis. I mean, there are international test points that you need to observe, and we definitely do deploy antenna patterns to make sure that we observe those international test points and we mitigate interference into adjoining territories, especially across the short distances across the channel towards France and Belgium and the Netherlands. So we definitely take measures to make sure that we don't provide destructive interference to other locations. Yep.
Hans, for example, in Italy, I don't know, maybe now all this has been corrected, but at the beginning, when the neighboring countries on the other side of the sea were starting to build networks, did you suffer interferences there, for example, from Croatia, or that's not something that you have been experiencing?
Well, first of all, we have only 2 minutes left, so we'll have to wrap up this. However, to answer Luis, in Italy, we had, before implementing the current plan for DAB, we had a few interference issues, but as long as you stick to the international coordinated plans, there is actually no big issue. We try, of course, to limit emissions towards the sea, also because having the geographic conformation of Italy, you might really incur in self-interference along the coastline. So it's not advisable in any case to broadcast with too much power towards the sea. And Italy has also some big islands like Sicily and Sardinia, where you really have to avoid incoming interference from the mainland. So, or vice versa, to interfere to the mainland.
Okay.
Okay, so thank you all for being in this seminar. I think our time is up. We have 1 minute left. I want really to thank Phil, Martin, Luis for their presentations. I think they've really been very, very interesting. And I hope the material they have presented will be useful for everybody in, let's say, in the development of their DAB networks, in managing issues correlated to synchronization. Let me thank also Becky and Michelle for organizing the seminar and for presenting also the activities of WorldDAB. And I think this takes us really to the end. Thank you all once again, and I wish you all a great day. Thank you for being here with us. See you soon somewhere.